Hello everyone, welcome to Jagadish College of Science, and this is from Mathematics Department. I am Jagadish Matha, your new mathematics lecturer. Some of students from your batch already know me, and I am new for remaining students. Okay, so today onwards, I am going to take B.Sc. 5.2 mathematics classes, and you guys already know that the syllabus is changed from your batch only. That is, your batch is the first batch to study the new CBCS syllabus. Okay. According to the new syllabus, your B.Sc. 5.2 mathematics syllabus is Laplace transformation. Okay. So here, the new B.Sc. 5.2 syllabus, CBCS syllabus is Laplace transformation. So total teaching hours of this Laplace transformation subject is 30 hours. This Laplace transformation subject has two units. First one is Introduction to Laplace transformation and second one is Applications of Laplace transformation. Both chapter will take 15 hours to each total hours. Okay. Now we start the first unit in Laplace transformation, that is Introduction to Laplace transformation. Okay, it takes total teaching hours is 15 hours and it carry 30 marks. So before going to start the topic Introduction to Laplace transformation, first we will know what we are going to study in this topic. So first one is definition of Laplace transformation, linearity property, and Laplace transformation of some standard functions, properties of Laplace transformation, first shifting property and second shifting property, then inverse Laplace transformation, and computation of inverse Laplace transformation by partial functions. Okay, these are the some importance to have to study in this topic. Okay, now Laplace transformation. Before going to the main topic, first we will know what is mean by a transform. Okay, what is mean by transform? So transform is a technique. Listen here carefully. Transform is a technique which the given problem is converted into different type of problems. That means the given problems is converted into different type of problems. Okay. Instead of solving the given problems, we solve the transferred problems, which is easier to solve the problems. Okay. Next, Laplace transform. Laplace transform. It is a powerful tool for solving the differential equations or linear differential equations with the given boundary values or boundary conditions. Okay. The next is the definition of Laplace transformation. This is important one. The definition of Laplace transformation. Here, let f of b any function. F of b a function of a real variable t. Okay, let f of b a function of real variable t defined for t is greater than 0. That is, t is positive terms. And Laplace transformation of f of t. So Laplace transformation of f of t is denoted by L of f of t. Okay, L of f of t or capital F of s, and is defined by L of f of t is equal to integrate over 0 to infinity e to the power minus st f of t into dt, where t is an positive integer. Here the L is called Laplace transform operator and L of f of t is called a Laplace function of the parameter s, and f of t is a function and S is a parameter of real or complex numbers. Okay, so f of t is a given function. L of f of t is Laplace transformation function of the parameter S, and S is the parameter of real or complex numbers. So here one note is there. The integrand over e to the power minus st is a function of S sin t. Okay, the integrand over e to the power minus st is a function of S sin t. When the integrand with respect to t, when we integrated the function with respect to t and substitute the limits of t, that is 0 to infinity or whatever it is there, then the resultant function will be yes only. Okay, the resultant function is yes only. That's why we write it is as L of f of t, or maybe we denote it as f of s or f bar of s. Okay, f of s or f bar of s. So the next property is, okay, next property is linearity property. So linearity property, before going this, we solve some similar property of this because it get easier to solve the main linear property. Okay, the first one is the Laplace transformation of constant value into function. Okay, see here carefully. Constant function into constant value into any function here. Wait. Okay, constant function into constant value into a function is equal to the constant function as it is and the remaining Laplace transformation with function. Okay, and proof, we know that the definition of Laplace transformation. Laplace transformation of f of t is equal to integrand over 0 to infinity e to the power minus st f of t into dt. Okay, so the function as it is, and with this function we have one constant value. Okay, so we substitute the here the Laplace transformation of constant value into function is equal to integrated over 0 to infinity e to the power minus st k into f of t dt, k into f of t dt, and the constant function will remain same in any integration formulas. Okay, it remains same, though that's why we take it outside the constant function k as it is, and the remaining function integrate over 0 to infinity e to the power st e to the power minus st f of t into dt. Okay, so here the k as remaining same, and this function is none other than the Laplace transformation of a given function. So hence we got here Laplace transformation of any constant value into function is always equal to constant function into that Laplace transformation function. Okay, I hope this one is clear. So we will go next property. So Laplace transformation of any two functions, okay, any two functions f of t or g of t. Okay, it may be plus or minus, it may be plus or minus, it will separate it. So Laplace transformation of f of t plus or minus g of t is always equal to Laplace function of first function and Laplace function of second functions. Okay, we will prove this one. Proof, we know that what we know, the definition of Laplace transformation. Laplace transformation of f of t, that is any function, is always equal to integrate over 0 to infinity e to the power minus st f of t dt. Okay, the f of t value is here. We will take this one. So substitute this value here. Laplace function of f of t and g of t. It may be addition or subtraction. Okay, it may be addition or subtraction. So when we substitute the values here, integrate over 0 to infinity e to the power minus st, and f of t is f of t plus or minus g of t. Okay, so here the addition or subtraction, whatever it is there. Now we solve this one step by step. Integrate over 0 to infinity as it is, e to the power minus st as it is, and this function will separate it to integrate f of t of dt. Then it may be addition or subtraction. Integrate over 0 to infinity e to the power minus st and g of t into dt. Okay, this is basic property, you already know this. Okay, now it becomes, now we get two separate functions here. Okay, two separate functions here. This one is called Laplace transformation of f of t, means one function, and this one is also called Laplace transformation of another function, that is g of t. Okay, so hence we got here Laplace transformation of f of t plus g of t is always equal to Laplace transformation of f of t plus or minus Laplace transformation of g of t. Okay, I hope this one is also you understand. So now here the main linearity property comes. Linearity property. Okay, linearity property. So statement of linearity property is, if Laplace transformation of two functions f of t and L of g of t are the Laplace transform of a function f of t and g of t respectively, and a and b are any two constant, then, or it may be comes in different, or it maybe comes in different statement, if f of t and g of t are two functions, f of t or g of t are two functions whose Laplace transformation exists, and if a and b are any two constant. Okay, the statement read carefully. If f of t and g of t are two functions whose Laplace transform exists, and if a and b are any constant, then the Laplace transformation of constant value into first function plus constant value into second function is always equal to the constant value remains same, and the Laplace transformation of first function plus second constant as it is, the Laplace transformation of second function as it is. Okay, we're going to prove this one. Proof by the definition. Okay, by the definition we know that Laplace transformation definition, the Laplace transformation of f of t is equal to integrate over 0 to infinity e to the power minus st f of t dt. Okay, this is definition is Laplace transformation. So in this, the function f of t we will have, okay, in this f of t function we have these total functions. Okay, instead of f of t we will substitute these values. Okay, Laplace transformation of first constant function of f of t and second constant value of g of t is equal to integrate over 0 to infinity e to the power minus st, and here the value constant value of first function and constant value of second function. Okay, when we solve this one, we'll get here. Okay, when we separate this term, okay, here integrate over 0 to infinity e to the power minus st, the first function of f of t plus the second function over integration 0 to infinity e to the power minus st b of gt. Okay, now we already solved the previous problem. The constant function of any function, okay, the constant value of any function. So there we solve k and here is a. Okay, so a as it is and integrate over 0 to infinity e to the power minus st f of t plus the constant value of second function b integrate over 0 to infinity e to the power minus st gt as it is. So again we'll got two functions here, f of t and g of t, and the constant values are remaining same. A and this function will call Laplace transformation of f of t because the function is f of t, and plus b as it is constant term, and the Laplace transformation of g of t because the function is g of t. Hence we get here Laplace transformation of any two constant values or any two functions. We'll separate, we'll get the answers here. Okay, so next we'll study Laplace transform of some standard functions here. Okay, Laplace transform of some standard functions here. What is standard functions? So standard functions, instead of calling standard function, we call it as a basic formulas. Okay, so just we solve this function. Just we solve the problem, previous problem. Laplace transformation of any constant value. Okay, Laplace transformation of any constant value. We solve this one. We know that already the definition of Laplace transformation. Laplace transformation of L of f of t is equal to integration over 0 to infinity e to the power minus st f of t dt. Okay, this is our Laplace transformation definition. According to this, we are going to solve the given function. So here the f of t value is 1. So instead of writing f of t, we will write here 1. Okay, so integrate over 0 to infinity e to the power minus st and the given function is 1 into dt. When we solve this function, when we solve the integration function, the constant function goes out and the integrate over 0 to infinity e to the power minus st becomes e to the power minus st divided by s. When we solve the integration functions, we will get this function, and the limits are 0 to infinity here. Okay, and the s is constant function, it remains outside. Then the functions e to the power minus st and okay, here the constant function minus 1 divided by s as it is, and we apply the limits, upper limit minus lower limit here. Okay, so here e to the power minus st. Okay, e to the power minus st, e to the power minus st, we substitute t as infinity. So we will get here e to the power minus infinity minus lower limit e to the power 0. Okay, e to the power 0 here. Next step is, so 1 divided by minus s as it is, and this function will get 0 here. Okay, how? Wait, I will show this one. Okay, integration over minus infinity is, we will write it is 1 divided by e to the power e to the power plus infinity. Okay, so here we'll get 1 divided by the any function to the power infinity is get infinity, and now 1 divided by infinity will call 0 here. Okay, and this function becomes 0, and you already know that any term of 0, any to the power function 0 is 1. Okay, and minus into minus function we will get plus here, that is Laplace transformation of any constant value is equal to 1 by s. Okay, check here. The function Laplace transformation of 1 is equal to 1 by s. Okay, one more property is there, important property. Laplace transformation of e to the power at, e to the power at. So instead of f of t, we will write here e to the power at. Okay, solve this one. Solution with we know that the Laplace transformation definition, Laplace transformation of f of t is equal to integration over 0 to infinity e to the power minus st f of t. Okay, so instead of writing f of t, we will write e to the power a of t. Okay, so as it is step by step, integration over 0 to infinity e to the power minus st f of t is e to the power at, and dt as it is. So here we get some basic problem. Okay, a to the power m and a to the power n, a to the power m and a to the power n will get e to the power minus st plus at into dt. Okay, so t is the common function here, we will take separate, it is e to the power minus s plus a into t. Okay, I want this term into positive, that's why we take e to the power minus common s minus a into t. Okay, into dt as it is, and this function will becomes e to the power minus, sorry, e to the power minus s minus a into t into dt. When we apply the integration over here, when we apply the integration here, we will get integration over e to the power minus of s minus a into t, and the constant term minus s minus a becomes denominator. Okay, this is constant function, so we will take outside here 1 minus, sorry, 1 divided by s minus a function into this function, we will apply here lower limit into upper limit. Okay, the upper limit is minus infinity and the lower limit is 0. Okay, so last problem only we will know that the e to the power minus infinity becomes 0, and e to the power 0 to the power 0 is 1. Okay, and minus of 1 divided by s minus a and minus 1 is becomes capital of, sorry, positive term of s minus a, 1 divided by s minus a. So the Laplace transformation of e to the power at is equal to 1 divided by s minus a. I hope this one also you understand. Okay guys, so there is assignment for you, and you guys already know that you have to make 3 separate notebooks, one for classwork and one for lab and remaining one for assignment. Okay, today going to give a first assignment. You have to write in assignment book, or you have to send me through WhatsApp. The first assignment is introduce, means introduction to Laplace transformation. First question is introduction to Laplace transformation and definition of Laplace transformation. Then the third of linear property. In that we solved plus function here. Okay, the Laplace transformation of constant value into first function minus second constant function into second function. Okay, so we solved plus function here. So I will giving you assignment as a minus function. Then Laplace transformation of L of 7. So we solved here Laplace of one function here. Okay, so you have to solve Laplace of 7. Then fifth question, Laplace transformation of e to the power kt. We just solved e to the power at. So a is constant value and k is also constant value. Okay, I hope you guys understand the today's class. If you have any queries and any doubts, please ask me on my WhatsApp number. Okay, thank you all. Thank you, one and all.